Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules.
Welcome to Lesson 16. Graphs can solve equations too. Classwork opening exercise. Okay, so since it is an exercise, that means you try it on your own. So pause the video, see if you can do this, unpause the video, and check your solutions. Okay, here we go. So solving for x in the following equation, which is an absolute value function, the first thing you want to do is check to see if there's anything outside the absolute value function on that side of the equal sign. So since there is, we need to get rid of that first. That means we want to isolate the absolute value. So we take absolute value of x plus 2. Negative 3 plus 3 is 0. That cancels, and we end up with 0.5x plus 4 on the right. Okay, that's a sloppy x, but anyhow, let me fix that. X plus 4. Okay, so now once we have the absolute value by itself, what we're going to do is take what's in the absolute value bracket and set it equal to the positive and negative on the right. I'll do one in green over here, so we would get x plus 2 equals 0.5x plus 4. We are then going to take that same equation, x plus 2, what's in the absolute value brackets, set it equal to the negative of this 0.5x plus 4. All right, so let's do this one over here first. Move the 0.5x over to the left. So I'm just going to quickly do this. Subtracting a half x from both sides, this will cancel, and 1 minus a half is a half. And then moving the 2 over here, subtracting 2 from both sides, I would get 0.5x equals 2. Multiply both sides by 2, and we get x equals 4. On this side here, we distribute the negative, so we would have x plus 2 equals negative 0.5x minus 4. Don't forget to distribute to both terms. And then I'm going to add a half x. So 1x plus a half x is 1.5x, or 3/2 x plus 2 equals negative 4. Subtract 2, and we get, I'll do it over here, 3/2 x equals negative 6. Multiply both sides by 2/3, and these cancel, and we get x equals, multiply this side by 2/3, and we get 3 to make this 6, a 2, and negative 2 times 2 is negative 4. So we get x equals negative 4, or x equals 4. And we always say or. You don't say and. X cannot be positive and negative at the same time. And I always check. 4 plus 2 is 6. Absolute value of 6 is 6. 6 minus 3 is 3. 1/2 of 4 is 2 plus 1 is 3. 3 equals 3. Put negative 4 in here. Negative 4 plus 2 is negative 2. Absolute value of negative 2 is positive 2. Minus 3 is negative 1. Half of negative 4 is negative 2. Negative 2 plus 1 is negative 1. So they both check. Those are our solutions. Okay, so I just erased all that just to get it out of the way for number 2. And it says, now let f of x equal the left side and g of x equal the right side. So really what we're doing here is saying this is f of x and it's equal to g of x. One is the absolute value function and one is a linear function. And we're going to graph these, see where they intersect, and the intersection point would be the solutions. And remember the two values we got. I'll write the answer up here again. We got x equals negative 4 or x equals 4. Now we're going to check this graphically. Okay, so A, graph y equals f of x and y equals g of x on the same set of axes. So if I graph the absolute value of x plus 2 minus 3. Let me just do a table of values. Okay. So I want to know when this is 0, and the absolute value is 0. So what this means is the absolute value of x looks like this, just real quickly. Actually, it goes up 1. Okay, it's a v. So let me try to do this more neatly. So if I drew that there and that there, okay, I'm just explaining what numbers do to the parent function. Okay, so here is the graph. Let me just grab this pointer. This is telling it if you're inside the brackets or parentheses, that's a left-right move. That's a horizontal move. The value outside is a vertical move. And it's opposite inside, the same outside. So opposite of positive 2 is negative 2, which means left 2. So that would move this to here. And then down 3. 1, 2, 3. Okay, so that would put this function here. All right. And then it would continue, of course. Let me fix that. Like so. Okay. All right, so there is x plus 2 equals negative 3. Now, let me show you using points. If you know where your vertex is, that's when this is 0. So you want to know when actually the 0 here would be negative 2, negative 3. That is the vertex, negative 2, negative 3. So what makes that the minimum or maximum is where those point, where the graph shifts. So negative 2, negative 3 would be our vertex, and there's the point. Left 2, down 3, boom. And then we just choose a couple points on either side. So if I go to the left, negative 3 plus 2 is negative 1. Absolute value of negative 1 is 1. 1 minus 3 is negative 2. And that would be negative 3, negative 2, and that is right here. So I'll put a dot there. This was our vertex. And if I go out to, let's say, negative 5, watch what happens. Negative 5 plus 2 is negative 3. Absolute value of negative 3 is positive 3. 3 minus 3 is 0. That is the point negative 5, 0. So there's those 3 points. Now if I graph on the other side, let's choose negative 1. Negative 1 plus 2 is 1. Absolute value of 1 is 1. 1 minus 3 is negative 2. So that's negative 1, negative 2, which is here. If I substitute in 0 for x, 0 plus 2 is 2. Absolute value of 2 is 2. 2 minus 3 is negative 1. 0. Negative 1 is here. Now let me pick a value like 5, just to show you that this works. 5 plus 2 is 7. Absolute value of 7 is 7. 7 minus 3 is 4. That's the point over 5 up 4, right here. Okay, so there's that graph. And now we're going to graph g of x. Well, that is I'm not going to take the time to do a t-chart. This is a linear equation. We've done plenty of these in algebra, pre-algebra, math 8, math 7, and so forth. The y-intercept is 1, which is right here. And the slope is 1/2, meaning up 1, right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2. And then I'm going to draw my line. Like so. All right, so keep in mind that these go on forever. And there is our graph of our absolute value function. That is f of x on the left, and g of x is a linear equation on the right. and they cross, their point of intersection is here and here. This is the point 4, comma, 3, and this is the point -4, comma, -1. So there's our solutions. X equals -4, x equals 4. Okay? So at B says, when does f of x equal g of x? Well, we just said that. What is the visual significance of the points where f of x equals g of x? It's where they intersect. So f of x equals g of x when x equals 4 and when x equals -4. The point 4, comma 3 and -4, -1. The points where f of x equals g of x are the intersections of the graph of f and g. Part C. Is each intersection point x, comma y an element of the graph f and an element of the graph g? In other words, do the functions f and g really have the same value when x equals 4? What about when x equals -4? Okay, well, when we plugged in the value of 4 here, we already did it. That was in my check in problem 1, so we've already answered this question, so let's just put it into words and be done with it. So this here is just a nice, neat electronic version of what I said and did in problem number 1. And it says, yes, you can determine this by substituting in -4 and 4 into both f and g. So when we put -4 in, we got -1. When we put -4 in, we got -1, so they're checked. Put 4 in, we got 3. Put 4 in, we got 3, and they checked. So that was just our checking when we did number 1. Okay, page 2 brings us to example 1. Solve this equation by graphing two functions on the same Cartesian plane. Negative absolute value of x minus 3 plus 4 equals the absolute value of 0.5x. And then that's minus 5. Subtract 5 from that absolute value. Okay, so we have absolute values on both sides of the equation. So we're going to let f of x equal the left side. We're going to let g of x equal the right side of the equation. We're looking for values of x at which the functions f and g have the same output value, the y. Therefore, we set y equals f of x and y equals g of x. We can plot the graphs on the same coordinate plane. So remember, the transitive property says that if a equals b and a equals c, then b equals c. So if two things are equal to the same thing, they're equal to each other. So if we let f of x and g of x both equal y, we're saying f of x equals g of x, which is what we're saying here. Okay, so let's take a look. I'll do f of x in red. And there's no need to do a t-chart. We can just do this. Well, we could, but this is going to be opening down because of the negative in front of the absolute value. This -3 inside tells us it was moved to the right 3. Opposite, remember, inside? So this is shifted, so it's a V shifted right 3 and up 4. So if I put a dot right here at the point 3, 4, that is our vertex. So if I plugged in 3, 3 minus 3 is 0, absolute value of 0 is 0, -0 is still 0, plus 1 is 4, and boom, right there. So if I did do a t-chart now, like so, and I know my vertex is 3, 4, and I want to choose 2 points on both sides of that, then I could go 2, 1, 4, and 5, and substitute in and solve. And that's what I will do. So I put 1 in here. 1 minus 3 is -2. Absolute value of -2 is 2. -2 plus 4 is 2. So over 1 up 2. Plug in 2. 2 minus 3 is -1. Absolute value of -1 is 1. -1 plus 4 is 3. So this would be over 2 up 3. And then if I go the other way, 4 minus 3 is 1. Absolute value of 1 is 1. Negative of that 1 plus 4 is 3. So that means I go over 4 up 3. And 5 minus 3 is 2. Absolute value of 2 is 2. -2 plus 4 is 2. So that would give me this here. So now, just to be nice and neat, I'm going to choose my line and I'm going to draw this very neatly. So the slope is a -1, so that's going to take me all the way up to there. And then if I do the same here, it's going to take me down to here. So there's my equation graphed, f of x. So I'm going to just put arrows here because we know they go on forever and ever. So that is this equation f of x graphed. Now we will graph g of x in green. So now we're going to do g of x in green, and this one is opening upwards because the absolute value function is positive. There's no negative in front like this one, so that's going to be a v opening up, and 1/2 of x minus 5. So to make this 0, so if I substitute in 0 in this case, 0 times 0.5 is 0, absolute value of 0 is 0, minus 5 is -5. There's my y-intercept, okay, right here. And then we're going to choose values on both sides of that. So I'll do a t-chart over here. And the middle we chose as 0, -5. And we are going to choose -1, -2, 1, and 2. So if I plug in -2, actually I don't want fractions, so let's do evens only, because half of an even is still an even, half of an odd would be a decimal or fraction, and let's avoid fractions. So sometimes you want to think about what the function is saying to make your life easier. So that's one of the ways to make these problems easier. Okay, so half of 3 is 1.5. I don't want to deal with fractions, so let's do just even numbers. So I'll go left 2 and left 2 more, right 2 and right 2 more. So -4 times 1/2 is -2. Absolute value of -2 is 2. 2 minus 5 is -3. So I plot the point -4, -3, which is right here. Plug in -2. I'm sorry, that was not right. It's -4, -3, which is right here. And sometimes when you're doing this, you find the solution when you choose a value. There is a solution. We are crossing the red line right at that point. So that is a solution right here, -4, -3. I'm going to continue now. Half of -2 is -1. Absolute value of -1 is 1. 1 minus 5 is -4. Left 2 down 1, 2, 3, 4 is right here. Then I substitute in 2. Half of 2 is 1. Absolute value of 1 is 1. 1 minus 5 is -4. So I'm going to go right 2, down 4. And notice that these are mirror images. Half of 4 is 2. Absolute value of 2 is 2. 2 minus 5, -3. So 4, -3 is here. Go up, choose my segment. Let's make it green. And we're going to continue up. So see what it is. It's up 1 over 2, up 1 over 2. That's our slope. Up 1 over 2, up 1 over 2, up 1 over 2. We want to be really accurate here because then we are finding solutions to the equation. Oops. What did I just do? Okay. Let's use purple for our solution. So here is where one of the solutions was, and here's where we cross here. And let me now finish the other side of this function. So up 1 over 2, up 1 left 2, up 1 left 2 would get us to the right there. Okay, so then I'm going to switch back to my marker, and I'm going to put arrows because those go on forever and ever. But what we're looking for is where they intersect. So from the graph, we see the two intersection points are -4, -3, and 5, 6, 7 over 8 down 1. So it's 8, 1. -4, -3, and 8, 1. Okay, the fact that the graph of the functions meet at these 2 points means that when x is -4, when x is -4, both f of x and g of x are -3. So when x is -4, y is -3. Or when x is 8, both f of x and g of x were 1, negative. I forgot my negative there. over 8, down 1 is 8. Negative 1, my apologies there, just caught that, negative 1. Thus the expression negative absolute value x minus 3 plus 4 and the absolute value of a half x minus 5 are equal when x equals negative 4 or when x equals 8. Therefore, the solution set of the original equation is solution set negative 4, comma 8. And there we have it. Okay, page 3 brings us to example 2. Solve this equation graphically. So this is an absolute value equal to a linear. So we're going to get a V-shaped function, and we're going to get a line. Write two functions repeated by each side of the equation. So we're going to let f of x equal the left side, which is the negative absolute value of x minus 3.5 plus 4. And we're going to let g, leg g, leg t, let g of x equal the linear equation negative 0.25x minus 1, where x can be any real number. Okay, so we will graph this in red and we'll graph this in blue. So t-chart x comma y, if you will. Alright, so this moves right 3.5 up 4. 1, 2, 3.5 up 4 is right here. 3.5 comma 4. This tells us it's opening downward. Okay, so I don't like fractions, so we're going to use fractions to get rid of the fraction for the y values. So we're only dealing with fractions on the x. Okay, so if I take 1 point to the left, that would be 2.5. 2.5 minus 3.5 is negative 1. Absolute value of negative 1 is 1. Negative 1 plus 4 is 3. So I go over 2.5 up to 3, and that is right here. Okay. Let me check something. Okay, so I just cleaned that up a little bit. Those dots were messy. All right, I'm going to go 1.5. And 1.5 minus 3.5 is negative 2. Absolute value of negative 2 is 2. So negative 2 plus 4 is 2. So this is going to be 1.5 comma 2 right here. Okay, so again, that's hard to draw with this pen. Very small graph. So just touch it there. Okay, so there's those 3 points. Go to the other side, 4.5. 4.5 minus 3.5 is 1. Absolute value of 1 is 1. Negative 1 plus 4 is 3. 4.5 is here, up to 3. And then if I do 5.5, just to save time, this is going to repeat. It's going to be 2. So 5.5 up 2 is here, and I'm going to draw a nice, neat line. If you're doing this on paper, obviously you would use a ruler. And what is our slope here? Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on. Middle, 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 middle. I'm just trying to be really accurate. The further out you go, the more accurate you are. There's one, and there's the other. Halfway between negative 1 and negative 2 right there. Okay, so there's our f of x. All right, now I'm going to graph this line in blue. y-intercept -1, which is right here. Slope is -1/4, which means down 1, right 4. So if I go down to 2, I'm over at 4. Down to 3, over to 8. Up to 0, over to -4. Up to 1, over to -8. Is that right? No, because that's a negative. Yes, that is right. That is a negative slope. Okay, so then I take my line segment. The reason I pause there is because the key's wrong. And let's see, we're going to be over 1/2 when we go 2. That's too thick, I'll fix that. Let's just undo it and choose a thinner line. I forgot to choose that. And here we go. Okay. And there it is. So then we need to determine where those cross. So it looks like right here. And that's going to continue. It's off the grid where it crosses over here. Okay, so whoever wrote this problem didn't do a very good job at choosing values that would be on the graph. How am I supposed to know what this point is? Good question. This point here isn't even an integer, so usually if you're going to make an equation like this for a textbook, the solution would be an integer so you aren't estimating your answer. So in this situation, I'm going to take my calculator and just show you if you run into a problem like this, because nothing is perfect, people make mistakes. So we need to determine this exact point. So I'm just going to show you now, since we haven't done this yet, how to do this in the calculator to get an exact value. So our one equation is, we're going to go to y equals and do negative, and for absolute value you press math, arrow over to number, and it's number 1. So I'm going to take the absolute value of x minus 3.5, arrow outside my absolute value, and put plus 4. Now if I zoom 6, there's my graph, and that is this red line, this red graph here, where my vertex is. Now if I hit trace, I have the point 0, 1/2, which is right here. And if I go up, how about I do second calculate maximum? Okay, and it's asking for the left side, enter. And then scroll over to the right side and hit enter twice, and that will tell us it is 3.5, 4. 3.5, 4. Okay, so there's that one. Now I go to y equals, arrow down, put our negative 0.25x minus 1 and graph that. And there it is, and see how it's off this screen here because it's past 10, just like here. We need to change our window, and let's make our x maximum 15 and hit graph again. Okay, so now there's our line crossing at 2 places, and now I can use my calculator to find the intersection points by saying second calculate, intersect is 5, and this says first curve, so it's on the absolute value function. I want to be down near where I'm intersecting since there's 2 answers. So you want to put the cursor close to the intersection point and hit enter. Second curve, now it's on the line near the crossing point. Hit enter again, hit guess. And the answer is -1.2, comma, -0.7. So one answer is -1.2, comma, -0.7. Okay, so that's what this value is here, -1.2, -0.7. You would never have been able to guess that by looking here. Well, you could have guessed it, but it would have just been that, a guess. Now we're going to hit second calculate, intersect for 5. Now I'm going to scroll over near the other intersection. I'm on the absolute value function, and I hit enter the second time. And then it's going to choose that intersection point, which is 11 1/3 and -3.83 repeating. Okay, so I'm going to go to my calculator here. I'm going to go, what is 0.83 repeating? And if you just do this until you go off screen and hit enter, and then hit math, enter twice, it'll tell you the fraction, which is 5/6. Just a little trick for you there. And then, so if I just hit, oops, no second, just graph. Where's my graph? Okay, so now if I do that again, second, calculate 5, enter 3 times when you're really close to it, 11 1/3. I'll just do it like this because it repeats. 11 1/3, comma, -3 5/6. Okay, so wouldn't that be just a beautiful example to show students when there's a new function? Okay, but anyway, I will stop. Part D, verify that the x-coordinates of the intersection points are solutions to the equations. Now they want us to substitute these values in, so I will do that. So what they're saying is you want f of x, which is y, negative 0.7 equals negative absolute value of the x, which is negative 1.2 minus 3.5 plus 4. Negative 0.7 equals a negative, and negative 1.2 minus 3.5, really quickly do it this way, 2.3, and it's going to be negative 1.2 minus 3.5, that's not right, you want to add. Okay, eraser. When they're both negative, you add and keep the sign. That's, remember those rules from, I think, Math 6 or earlier. It's 4.7 negative. So negative 1.2, and then left 3.5 from there is negative 4.7 plus 4. So I get negative 0.7 equals a negative, and that is a positive 0.47. Negative 0.47, absolute value is 4.7, and then you take the negative of that, again it's negative 4.7 plus 4. So negative 0.7 equals, well, negative 4.7, and you add 4 to it, it's negative 0.7. So that checks. Okay, so then we do the same in the other equation. So we let g of x be our y, which is negative 0.7 equals negative 0.25x, 11 1/3, minus 1. Okay, so I've got decimals and fractions, I will fix that. So this is going to become negative 1/4. Negative 0.25 is negative 1/4. I will change this to 34/3 so we can take care of these fractions. 34/3 is 11 1/3. Okay. So now when we do this, we get 34/12. So negative 0.7 equals, and we're multiplying, so it's negative times the positive is negative, 34/12 minus 12/12, because that's 1. Negative 0.7, and how about we just make that a fraction since we have fractions on the right. 0.7 is 7/10, so it's negative 7/10 equals negative 34 minus 12 is negative 46/12, and then cross multiply. 7 times 2 is 14, carry the 1, 7 times 1 is 7, plus 1 is 8. So when I take negative 7 times 12, I get negative 84 equals 10 times 4.6, that's not right. I made a mistake somewhere, let me see. Let's undo. I know what I did, no I don't. Should have been negative 1.2. Whoops. Undid too many. That's all correct right to there. Okay, let's use a calculator to do this so I don't make another mistake on screen. That's okay though. Let's see. calculator. Second, quit. Clear. So we're going to let g of x. I think I plugged in. Oh, I did. I see what I did wrong. I took the y from here and the x from here, didn't I? Okay, let's not use the calculator. Let's do this right. So when g of x is, or y is negative 0.7 equals, and now we're using this equation here, but x isn't 11 1/3, it's negative 1.2. That's why that did not work. Negative 0.25 times negative 1.2 minus 1. Negative 0.7 equals 0.25 times 1.2, just to save time there, is 0.3. Negative times negative is positive. That would be 0.3 minus 1, negative 0.7 equals 0.3 minus 1, 0.0. 0.3 minus 1.0 is negative 0.7. Whew. Okay, that worked. One more time with the other solution. So that solution on the left, 1.2 here minus negative 1.2 comma negative 0.7 was true on both equations. Now we check the other one. Let's switch to purple this time. Alright, so now we let f of x be our y, negative 3 and 5, 6. 6 times 3 is 18. 18 and 5 is 23. That is a negative 23 over 6 equals. And then we're going to plug in 34 over 3 for our x in this. Negative absolute value 34 over 3x. Oops, that is x. Minus, there's our x, minus 3.5. 3 and 1/2 is 7/2. I want the same denominator, which would be 6. So what do I have to multiply 2 by to get 6? Well, that's 3. So 7 times 3 is 21. So 7/2 is 21/6. So we now need to make this a 6 by doubling it. And double 34 is 68. So 68/6. Absolute value plus 4, but we're in 6. So 4 times 6 is 24 over 6 is 4. Okay, little lesson in fractions again. Negative 68 minus 21 is 47 over 6. That would be positive, absolute value, but then we're taking its negative, plus 24 over 6. So we get negative 23 over 6 equals negative 47 plus 24, negative 47 plus 24. So what you do is you subtract and keep the sign of the bigger, and you get a negative 23. How cool was that? It matches. Negative 23/6, negative 23/6. I apologize for the mess. Oops. Went a little too high with my eraser. And we need to do this one more time. We need to check the this point in this equation. So let g of x be our y, which is this, which was 23/6 negative, negative 23 over 6 equals negative 0.25, I'll change that to a quarter, x, 34/3, right? 3 times 11 is 33, plus 1 is 34 over 3. 34/3 minus 1. We want these all to be 12 this time, right? 4 times 3 is 12, so we want these to be 12s. So double 23 would be negative 46 over 12 equals, and if I want 1 to be 12th, it'd be 12/12ths. Alright, so now when I multiply this, I get negative 34 over 12 minus 12 over 12. Negative 46 over 12 equals negative 34 minus 12 more is negative 46 over 12. I could reduce both of these, but why? They're equal fractions. Leave it alone. We just proved by plugging in these values into the equations, both of them work in both equations. That was a lot of work, but hey. Okay, page 4 brings us to exercises 1 through 5. Exercise means, guess what? Try it on your own. See if you can do this. Pause the video, then come back and I'll do them and we'll check your solutions. Just make me do all the work. Try it out. Okay, use graphs to find approximate values of the solution set for each equation. Use technology to support your work. Look familiar? Explain how each of your solutions relates to the graph. Check your solutions using the equation. So I'm going to graph 3 minus 2x on 1. So this I will do in purple, and this I will do in red. So this will be my f of x, and this will be my g of x. So f of x is the equation. Think of that as negative 2x plus 3. So the y-intercept is 3, which would be right here, and the slope is negative 2, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I just keep going so I get an accurate location. It's really important you're accurate when you do two graphs like this, looking for intersections. One graph is off just a little. You could be off by one whole number or more. Over 1 up 2, over 1 up 2, over 1 up 2. And then I choose my segment. And is there purple? Sure. And I start here and I bring it to there. Okay. And obviously arrows at the end. And then label it f of x. G of x is a absolute value. It'll look like a V. It's opening up because there's no negative sign here. It is not shifted up or down because there's nothing outside here, but it is shifted to the right 5. So my vertex is the point right there, 5, 0. Okay, so if I plug in 5, 5 minus 5 is 0. If I plug in 6, 6 minus 5 is 1. If I plug in 4, 4 minus 5 is negative 1. Absolute value of negative 1 is 1. So it's a linear equation going this way with a positive 1 for the slope and this way with a negative 1. So it's just up 1 over 1, up 1 over 1, up 1 over 1, and so on. And this is up 1, left 1. Until we get to that point right there, which is what we're looking for. Where do these two cross? So then I go and I get my line, make it thin, make it red, and make it work. All right. There she is. Now I just need to fix this just a bit. Okay, something like that. Anywho, there it is. Oh yes, and there are arrows here, and I will label that g of x. Okay, there's our solution right here. So it's negative 2, 7. So if I plug in negative 2 for x, these will be equal. Negative 2 times 2 is a positive 4. Let me just do it this way. 3 minus 2 times negative 2. 3 minus negative 4. 3 plus 4, 7. Plug in negative 2 here. Absolute value of negative 2 minus 5. Absolute value of negative 7. 7. So we got plug negative 2 into both of these. We got 7 for both. That is the only solution. They will never cross again anywhere. The solution is negative 2, 7. All right, let's keep doing this. This time I'll use green and blue. All right, this is an exponential function, and this is linear. So if I plug in values to solve this. So let's just do an XY table for this. Okay, so if I plug in 0, 0 there, 1.5 to the 0 power, anything to the power of 0 is 1. 2 times 1 is 2. So when x is 0, y is 2. So remember, if you know a times b to the x, a is your y-intercept, and b tells you if it's growth or decay. And if it's positive, it's growth. If it's a fraction that is less than 1, it's decay. All right, so I shouldn't say if it's positive. If it's a number greater than 1, it's growth. If it's a number between 0 and 1, it's decay. Okay, so 0, 2 is right here. If I plugged in 1, 1.5 to the first power is 1.5. 1.5 times 2 is 3. So it's 1 comma 3. So what this thing is going to do is going to get really, really close to 0 but never touch. So if I chose negative 2 or negative 1 here, that would be 2 times 1.5 is 3 halves to the negative 1, and the rule says to flip the fraction and make the exponent positive. So that'd be 2 times 2/3, which is 4/3. 4/3 is... Okay, so we have negative 1 as our x, 1 1/3 as our y. So that'd be like right here. So as you can see, this is going to come down and it's going to curve up like so, and then it's going to get big really fast. So if I plugged in 2, that'd be 1.5 to the second power, which is 6.25. No, 2.25. 2.25 times 2 is 4.5. So at 4.5, let me make that a little bit neater. Actually, let me undo it so it's not there at all. 4.5. So when I plugged in 2, I was at 4.5, which is here. So I kind of was going up too quickly, but it's going to curve up like this and continue down like this, but never across the x-axis. So it looks like that. Okay, it's hard to draw with this, bear with me. That is an exponential function growth. All right, now the other one's linear. That one's easier. I'll do that in blue. So if I plugged in 0, actually this is a y-intercept of 2, so there's my solution. And the slope is 1.5, 1.5, so that means up 3 over 2. So 1, 2, 3 over 2. 1, 2, 3 over 2. Down 1, 2, 3 over 2. I don't need to go any further. It crossed at the point 0, 2, and it crossed at this point. No, it didn't. Never mind. We're going to use technology to get the x exact. And blue. Did I make it thin? No. Alright. Alright, so there's our line. Let me extend it out so it's more accurate. Right there. Okay. So this is messy, but there's our 2 intersection points. I'll circle those in red. So there's one intersection point and there's the other. Somewhere around there. I will use a calculator now to verify this because it does say use technology to support your work. So I'm going to go to y equals. Clear what's there. And substitute in 2 parentheses 1.5 close parentheses to the power of x. There's my exponential function. I'll graph that right now before I go any further so you'll see what it does. It will not cross the x-axis. It comes up, crosses at 2, and keeps growing like this green curve I have. And if I hit calculate trace, whoops. Yeah, let's calculate 0. There wouldn't be 1. Never mind, that's clear. If I just trace, there's the point 0, 2. That's our y-intercept. Okay, now go to y equals. Arrow down. Put in our line equation, linear equation. 2 plus 1.5x. and graph. Boom, boom. Now see how it crossed here and here? It's hard to see, but it crossed around 3. So if I change my window to, we're only concerned with this point here and this point here, let's go from -1 to 4 on our x. So this is a little lesson in choosing a window so you can zoom in better. So let's go from -1 to 4 instead of -10 to 10. So second table set, whoops, not second, just table set, -1 x to 4. And hit graph. So we just narrowed it down a little here. There's the graph of the exponential function. There's the graph of our line. But this point here isn't quite 10. I could actually narrow that. I don't need all this space below the y-axis. So if I change my window of y minimum to -1, just so we can still see the axis, and bring this down to 8, it will zero in on our graph a little better. So watch this. Okay, so there's our exponential function. Here's our linear function. Boom, boom. There's where they crossed. So if I hit second, calculate, intersect, which is 5, put your cursor close to the intersection point and hit enter 3 times. That's basically all we're doing. We get the point. Now when you get -1.77 e to the -15, that is saying it's -1.77 and it goes out, and that's 0.00015 zeros till we get to 177. In other words, that is 0, 2. That's just a scientific notation. Remember, this is an estimate. The calculator was close, and it was 0.00000000000000177. That's pretty close to 0, 2. All right, now let's trace the other one. Second, calculate, 2 for 0. Now scroll your cursor close to the other intersection point and hit enter 3 times. Okay, 1, 2, 3. Error bound, quit. What do they mean by that? Graph, second, try that again, that was weird. We're looking, oh, I said 0, that's why. Second, intersect, 1, 2, 3. It never crosses the 0, so that makes total sense. So this is 2.7760469, comma, 6.1640703. All right, so let's come back to our graph here. Let me minimize that so we can see both. Let me erase this mess over here. And we're going to label our graph with our other solution. So that is the point. Let's do it, I guess, in the same blue. This would be somewhere around here, or here, I'm not sure where. But anyhow, it is the point 2.77, or 2.78, comma, the 6 makes that an 8, 6.16. That is 2.77, not quite 3, and just a little more than 6. Okay, so that's the solution. Okay, number 3. The graph of the functions f and g are shown. So it's a quadratic in red and an exponential in blue. Use the graphs to approximate the solutions to the equation f of x equals g of x. Okay, so all they're asking us to do is, what is that point? And approximate that point. So this point here looks like, oh, I don't know, -0.8. Oops, wrong place. -0.8, comma, not quite -1, and not quite 1. So that would be maybe, I don't know, 0.7, 0.8. Let's just say 0.8. So it's -0.8, 0.8. Remember, it's an approximation. Or over 2, up 1, 2, 3, 4. It looks pretty close to the point 2, 4. So let's just say that, 2, 4. Okay, so let me graph something for you just to explain something else too before we move on. Let me go back to zooming around the origin. Let me go to y equals. Oh, okay, let it finish. I should have done y equals first. Go to y equals, clear, clear. Okay, so let's just say we have an exponential function 2 to the x. And we have a parabola, just simply x squared, the parent function. Graph. Okay, there's our exponential function. There's our parabola. Let's zoom, change our window. I don't care about negative x's, so I go to window, and let's just leave -1 so we see the axis. So there's that. Okay, don't care about negatives, so change our window y minimum to -1. And let's change our x maximum to 20. And I want to point something out to you. There's our exponential function. Here comes the parabola. So it's still hard to see because now we don't want to go over more than what? 1, 2, 3, 4, 5. Let's change our window again to x max 5. There's our exponential. Here comes our parabola, crossed here, but look it went back outside. So this is the parabola. The parabola came up, crossed right here, it was over here on the left side of the absolute or the exponential function. Then it crossed again, and the parabola is going over here. So there is another solution up here higher, but it's off the graph. So just so that you're aware, there may be another solution somewhere over here when x equals 3 or 4. And in looking at this, it looks like it's closer to 4. So if I go second, calculate, intersect one more time, and scroll up to this other place of intersection and hit enter 3 times, it is the point 4, 16. So there's another solution, 4, 16. If that was the function 2 to the x. Okay, part B says let f of x equal x squared and let g of x equals 2 to the x. Find all solutions to the equation f of x, g of x. Verify any exact solutions that you've determined using the definitions of f and g. Explain how you arrived at your solutions. Well, you know what's funny? I put this in the calculator. See that 2 to the x? See this 2 to the x? I did not read ahead. That was just coincidental. Oh. Anywho, I chose the right value that they wanted us to do. And g of x, x squared, I just used the parent function there. So I've already done this. And so we verified that solution already, which was, so this has been verified. Now we want to verify the 2, 4. So we go second, calculate, intersect 5, scroll down, oops, let me use the mouse, scroll down to the other intersection point and hit enter 3 times. And we got the point 2, 4. All right, so guess what? That checks. But there's one more over on the other side, so I have to change my window back. So let's adjust our window. We want to be over on the other side now. So let's go x min -5 till +1. And then our max, let's only go to 5 because we know it's only 0.8. So I'm just narrowing it down to the small corner. Here's our origin, and that's where they're crossing right here. Here's our parabola. Here's our exponential function. They're crossing here. Second, calculate 5 for intersect. Scroll to near their intersection point and hit enter 3 times. And we get -0.766, 0.58. So this was a close approximation, but not close enough for my liking. So I would change that to a -0.76 or 77, which is pretty close to -0.8, but the y was off a little. Negative 0.587 is about a negative 0.59, rounding up to 2 decimal places. So we were off a bit on the y. Okay, okie dokie. Okay, page 5 brings us to number 4. The graphs of f, a function that involves taking an absolute value. Okay, so I'll stop right there. So this absolute value is f of x. And g, a linear function. So this line here is, let's change color, is g of x. Okay. Are shown to the right. Both functions are defined over all real values for x. Tammy concluded that the equation f of x equals g of x has no solution. In other words, she's saying they will never cross. Do you agree or disagree? Explain. So I'm going to zoom in for this. Let's go to 200. Maybe we can see it better there. Okay, so here it is. So what I want to do is, well, when two lines never intersect, it means the two lines are parallel. They have the same slope, different y-intercept. So obviously these two lines are going to cross at a different place. This is going to cross somewhere up here. This is going to cross somewhere down here. That's two different y values. Now we just need to prove that these lines are parallel or not parallel by checking their slopes. So let's start with this point right here, and that is the point negative 3, comma 0. And find the next point where they're on the corner of the grid, and that is the point negative 2, comma 5. Okay, so if we're going from negative 3 to negative 2, that's a change in x. And remember, change is y over x. So we're going to put our change in y, which is 5. We went up 5 over 1. So our slope of our right side of our absolute value function has a slope of 5. Now we're going to check the slope of the blue line. Well, they're both blue, but g of x. So I look for points that are on the corner of a grid, an integer x and an integer y. And that is the point 1, comma, negative 5. And then I look for another point where they're right on the grid. I don't see another one. Once we get over to 2, it's off the grid. So this one's going to be a little bit tougher, but all we have to do is use the slope from this, because we can't find another point to subtract. These are all estimates if you guesstimate. So we want to go up 5 over 1. So if I go up 1, 2, 3, 4, 5 over 1, now I got to move the name of that, it's in my way. So if I go up 5 over 1, I'm right here. Am I on that line? Nope. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So this green line that I would draw here, let me draw it just to clarify. That was beautiful. Okay. Alrighty then, I love it. Okay. Let's try that again. That's better. So obviously, this green line and this blue line aren't the same thing. They don't have the same slope. This one's the blue one's rising faster. So it does not have the same slope as, and as I'm pointing out, this is the same as my V. See how it sits right on top of that? It's got the same slope, where this one obviously does not. Okay, so different slopes means they will eventually intersect. They are not parallel. Somewhere up here, these two lines will intersect, so I disagree. Okay, so I disagree with Tammy because we cannot see enough of this graph. The graph of the function shown to the left has a slope of 5. The graph of the function shown to the right has a slope greater than 5. Therefore, these two functions will intersect somewhere in the first quadrant. We would have to zoom out to see the intersection point. Okay? All right. All right, so I've zoomed back out onto number 5. The graph of f, a function that involves taking an absolute value. Okay, so this blue upside down v is f of x. and g as an exponential function. So g is exponential. So that's the one that's curving up like this. So let me move this f of x over here, and let me call this g of x up here, just so that we're clear. This is g of x, f of x is the absolute value. Sharon said the solution set to the equation f of x equals g of x is exactly negative 7 comma 5. Left 7, up 1, 2, 3, 4, 5. Really? Do you agree or disagree with Sharon? Yeah. What did she do wrong? I don't know. It is crossing here. There's two solutions. One solution is here, and remember that is not 0 because this exponential function will never reach 0. It's got a horizontal asymptote. It will never cross. So this is 0.0001, something like that, comma, negative, or it's actually negative 7, comma, 0.001 something. So that is definitely not negative 7.5. Negative 7.5 is right here. This is not a solution to either of these. And then the other one is right here, and that appears to be the 0.5, comma, 16. So let's put this into words. Okay, so I disagree with Sharon. We would say that the solution set is approximately negative 7, comma, 5, but without having the actual equations or formulas for the two solutions, for the two functions, we cannot be sure the x values of the intersection point are exactly negative 7 and 5. I do not know what they are talking about here. There shouldn't be a negative here. I think they made a mistake when they made this solution. Negative 7, 5. Whoops, I'm up too high, by the way. This is 2's. So I'm at negative 7, 9. Negative 7, 5 would be right here. All right, so disregard this. I would say that it is not approximately negative, so let's delete that. Boom. Okay, so what they were probably saying was, I have no idea. That does not make any sense. I'll just stop there and say, disagree with Sharon because negative 7, comma 5 is not a solution on either of the equations. The approximate solution would be negative 7, comma 0.001, something like that, and or another solution would be or the 0.5, comma 16. Okay, page 6 brings us to the end of lesson 16. Go to your problem set.